So today we're going to go over the pH scale and how to calculate pH and what that actually means. Um, so we have to begin with the idea of pH, and you've studied pH in other science classes. You know that things that have a low pH are acids, and things that have a high pH are bases. Neutral pH is 7 and that sort of thing. But the idea of pH actually comes from the hydrogen ion. And so that's what we need to look at here first. So all solutions that are made in water, all aqueous solutions, have some hydrogen and some hydroxide. And that's because the water molecule actually dissociates and breaks apart like this. So if you have lots of hydrogen ions in your solution, then you have a low pH, and that's considered an acid. If you have relatively lots of hydroxide ions, you have a high pH, and then that's considered a base. And so it kind of sounds counterintuitive because if you have lots of hydrogen, it's a low pH. And if you have lots of hydroxide but very little hydrogen, you have a high pH. So it does have something of an inverse relationship, and we'll take a look at why that happens. Oops. So if I scroll down here, we can take a look at the pH scale. And again, you should be somewhat familiar from other science classes about the pH scale. But I've laid it out here for you. The things that have a high pH are things like drain cleaner and bleach and that sort of thing. Soap is actually a base. And they generally have high pHs. A pH of 7 would be pure water. Pure water is very difficult to get because as soon as a little speck of dust or something else gets into it, it's not pure anymore. And so it's very hard to have an actual pH of 7. And then things that are less than 7 are acidic. And, battery acid is one of the most acidic things that we know, but things like lemon juice and vinegar and those sorts of things are also acidic. All right, so hopefully you're a little familiar with the pH scale from previous science classes, but you can take a closer look at that too. To calculate pH, we're actually going to use a logarithm. And so for those of you who are in Algebra 2 or Trig or Pre-Calc or something like that, you've learned about logarithms. If you're not quite there in math yet, don't worry too much about it. It's a button on your calculator, and you can use that button without really understanding the concepts behind it. So to calculate pH, we take the negative log of the hydrogen ion concentration. And these brackets around hydrogen mean molarity. So concentration measured in molarity. So to figure out the pH of these solutions, we take a look at their molarity, and then we type in our calculator negative log of whatever that number is. So in this case, we're going to type in negative log of 2.2 times 10 to the negative 5. And remember to use that EE button in your calculators to do times 10. So when I do this in my calculator, I end up with a pH of 4.66. And we'll stick to either having 1 or 2 decimal places for our pHs because that'll keep us consistent. The significant figures actually get a little weird here. So just go ahead and do 1 or 2 decimal places and you'll be fine. So that's essentially how the calculator works. If we have brackets around something, a formula here, if it starts with hydrogen, it is an acid, and therefore it's contributing those hydrogen ions. So we calculate it the same way no matter what else is in that formula. The NO3 doesn't actually matter. We're still going to do the calculation the same way. And so negative log of 3.5 times 10 to the negative 3, we end up with 2.46. And so we can also do these calculations backwards, and I'll start that in part 2 of this video.